Okay, hello and welcome everybody to the finals of SensUs 2022. This is already the 7th edition of SensUs, and it has actually been 3 years ago already that we were able to have a live event here in Eindhoven, of course due to the COVID pandemic. So I think we're all extremely excited that almost all teams were able to come here to Eindhoven and demonstrate their biosensors to all of you today. So, my name is Eline Rutten. I will be your Masters of Ceremonies for today, so I will host you throughout the day. I studied biomedical engineering here on this university, graduated within the field of biosensing, and I was also part of the SensUs organization. So actually, I was also present during the first edition of SensUs, which was held in 2016. And I remember that back then, we actually weren't sure what to expect. Because building a working biosensor is actually a very huge challenge, because it's a very complex and multidisciplinary technology. But I remember that we were actually blown away by what all those 5 teams were able to achieve in only 1 year. And I think at that moment of time, we were sure that SensUs is a very special format for stimulating innovation and education within the field of biosensing. And I think it's very nice to come here every year, and then you can see and feel that SensUs is growing and developing every year further, because of course all those students are joining all the teams worldwide, but also the organization here in Eindhoven. New companies and partners get involved, and I think everybody brings something new to it. But also some things stay the same, because I was also here on Wednesday and I was talking to one of the students, and he said it's such an amazing experience. You work so hard during a year and then come here and meet all those students who worked on the same challenge but used different approaches, and this yields to very special connections. And I think I was very happy to hear that, because I felt exactly the same way already during the first year. So I think that's really the spirit of SensUs. It's a competition, but it's very friendly and with open innovation and with a lot of happy students. So I think we can all be very proud of the success that SensUs has become. And it's actually a very impactful competition, but also network within the field of biosensing. So now I'm very happy to introduce to you the first speakers of today. As you know, SensUs is organized for students by students, and the first speakers will be the chairs of SensUs, Vera and Hans. Give them a warm welcome.
Yes, thanks, Eline. Welcome to the SensUs event 2022. My name is Vera Turlinks, and I've been the chair of this year's organization.
Yes, and I'm Hans Daube, Vice Chair of SensUs 2022. With the entire organization, we've been looking forward to this day. And it's so great to see all of your faces here together in Eindhoven, because it really shows the diversity of this competition. And not just culturally, but you all have different professions, ages, backgrounds. You all bring something special to the table.
Yes, so last January we started the competition with the kickoff event. And since then, a lot has happened. So teams have worked very hard all year on their biosensor, and have also been supported by companies that are a partner of SensUs. And by sponsoring this competition, they help realize this event. And in addition, they also help the teams build their biosensor by providing feedback and expertise. Next to this, teams have also learned from each other. So some teams have met up online to exchange knowledge. Some teams met up in real life at each other's universities. And one team even organized an online game night.
Yes, and I'm sure especially the game night helped build the biosensors. Speaking of biosensors, today is the day that all hard work comes together and we get to see the final products that all of you created. We hope to see some good results, improving healthcare for the better.
Over the years, SensUs has focused on several different diseases and biomarkers, from heart failure to kidney disease or influenza. And today will be all about one specific disease.
Yes, this year's theme is acute inflammation with a focus on sepsis. Sepsis is an inflammatory response in blood, causing over 10 million deaths each year and affecting over 50 million people worldwide. So let's get to know a little bit about the experiences of sepsis survivor Idelette Nutma.
Sepsis is really an emergency, and I think a lot of people aren't aware of that, including professionals. 50 million people worldwide per year are affected by sepsis, and 20% doesn't survive.
Every hour of delay from treatment increases the chance of dying by 10%.
Using a biosensor to detect IL-6 and to detect sepsis early would really benefit care for sepsis patients.
Acute inflammation with a focus on sepsis.
Early detection, every second counts.
So that is why biosensors can be of such great value in places like the intensive care unit, where fast measuring can literally save lives. Last Wednesday, the team showed how fast they could test during the testing event.
Yes, as some of you may remember from 2019, the testing event was filled with focus, excitement, and sometimes a little bit of chaos. So let's take a look at how things went. So the results from the testing event will determine the winner of the Analytical Performance Award. For the Creativity Award, the teams will pitch the concept of their biosensor and what makes their design so novel. And for the Translation Potential Award, they will pitch their business model and how their biosensor can translate into the market. Last but not least, for the Public Inspiration Award, the winner will be based on your votes.
Yes, so the Creativity Award, the winner will be decided by an expert jury judging how innovative the biosensors are and how they work. As for the Translation Potential Award, we've assembled a panel of experts in both the industry and research to give a well-balanced judgment on the business models. The business models will be judged on 3 categories, which are the business, financial, and stakeholders' point of view. Last but not least, the winner of the Public Inspiration Award is in your hands. So as of this morning, the voting has opened. So make sure to decide on your favorite team before 4 o'clock today and cast your vote on Sensus Digital.
But most importantly, the whole Sensus organization invites you to enjoy this day, because after 2 online editions, we look very much forward to meeting you in person, to seeing your pitches, to maybe making a chat at the partner stands, and to fully enjoy Sensus. So thanks for coming, and now let's take a look at the 1-minute pitches by the teams to get a preview, and enjoy!
Hello everyone. We are Team Sense from Hangzhou, China.
Hi guys, this is Team TrueSense. Greetings from China. We are a team from Zhejiang University, and let's take a quick look at what true sensors usually do.
Hello, I am Yan Lei. Let me show you the true sense. Please follow me.
This is our lab in the Biological Experimental Center. Basically, we hold regular meetings in here, do experiments, and burn the midnight oil for those essays and data analysis. We're proud of what we've learned and achieved in this lab, and this is definitely going to be one of our best memories together. This is how our biosensor works. On screen printed electrodes, we designed 2 protocols to capture the IL-6 using MIP hosts and single-chain antibodies. After that, we determine the IL-6 concentration by measuring impedance changes with the EIS. The following animation serves as a diagrammatic sketch. During the preparation process, we have synthesized the single-chain antibody fragment, adjusted the electrochemical workstation, and explored the optimum modification conditions for electrodes. We're truly grateful for having the opportunity to participate in this competition. Although we cannot make it to the Netherlands because of the COVID-19 pandemic, we're still looking forward to meeting with you guys online. Best wishes to all of you from Team TrueSense, Zhejiang University, China.
Hello, we the Ixens team from the RWTH Aachen University developed an electrical biosensor for the detection of interleukin-6. Interleukin-6 is a cytokine in the human blood that can be used for the early detection of fatal diseases like sepsis, which affect a large amount of patients worldwide. Our main goals while developing our sensor were a fast and easy readout while keeping the long-term cost of our device at a minimum. This we tried to achieve through a readout system which facilitates disposable cartridges which can be easily swapped out. These cartridges are based on integrated field effect transistors with indium tin oxide biofunctionalized with interleukin-6 specific aptamers. This gives the opportunity for low-cost, large-scale production, but also gives us the opportunity to easily develop detection units for other biomolecules in the future. We hope that our sensor revolutionizes the way of detecting diseases. Stay tuned and we will see you in Eindhoven.
Current detection methods for interleukin-6 take too long to diagnose, and most of the time, if the patient is suffering from a disease such as sepsis, they could die from septic shock before the results come out. Our team at the AUC Chemistry Department brainstormed a rapid and quantitative detection method by constructing a biosensor that utilizes electrochemistry. This will allow us to easily add a point-of-care system that makes it portable, convenient, and easy to read for patients. While normally proteins are detected by antibodies specific to this protein only, antibodies have a short viability period and are very expensive. Our biosensor uses aptamers instead, which is much cheaper and very stable. During the actual process of detection, the compound ruthenium is used instead of the common ferrocyanide. The advantage of ruthenium is that it increases the sensitivity of the biosensor by binding to the backbone of an unbound aptamer and very scarcely binds to protein-bound aptamers. The intensity of the current is then detected and documented.
Hi, my name is Laudian, and on behalf of TEST, I will present you our biosensor, which will focus on the early detection of sepsis. We will focus on the elderly, since this group is harder to diagnose and have to be admitted to the hospitals more often, which will lead to a higher cost for our healthcare system, but also hospitalization has a huge impact on their social lives. Our test will be used by general practitioners to test the elderly with non-specific symptoms related to acute inflammation. The test can be done during the doctor's visit or during the house visits of the GP. TEST biosensor will detect IL-6 by using a sandwich assay, combining a fluorescent signal, magnetic washing, and excitation on a specific surface. The sensor complex can be expanded to a multiplex measurement, in which different inflammation markers will be measured at once, providing a more accurate data for diagnosing sepsis or other acute inflammations. Thus, TEST biosensor can reduce the impact of sepsis and increase the quality of life of elderly.
Bonjour. Hi, we are the Canadian team Biosensum. To detect and quantify IL-6, our team, composed of students from the Polytechnic and the University of Montreal, developed a biosensor that uses localized surface plasmon resonance technology on borosilicate tapered fibers. These fibers are coated with thousands of gold nanoparticles that are conjugated with IL-6 antibodies to detect the IL-6 concentration in a 20 microliter plasma sample within a range to 1 to 2000 picogram per milliliter in 5 minutes. The 40 nanometer nanoparticles were synthesized and conjugated in our lab by our team members. Thanks to our own case design and interface with a color-coded indication of the concentration of IL-6, our technology is super easy to use. Thank you for listening, and we look forward to seeing you at our booth.
Do you know how many neonates are unnecessarily treated with antibiotics because of false sepsis suspicions every day? In low and middle income countries, we are talking about more than 10% of these newborns, which comes at the expense of their health and also contributes to the global increase in antibiotic resistance. Now imagine having a test for early sepsis detection, allowing you to distinguish between a false suspicion and a true diagnosis. We here at Sense aim to revolutionize early sepsis detection. With our novel biosensor, we offer a cost-effective, rapid, and accurate solution. Using a nanoparticle-enhanced plasmonic biosensor, we can detect acute infection biomarkers, such as IL-6. Within only a few minutes, our device provides you with a neonatal sepsis diagnosis with close to 100% sensitivity. So, if you want to know more, make sure to come see our pitch.
Did you know? Sepsis causes nearly 11 million deaths per year worldwide. In Europe, during the COVID-19 pandemic, 78% of the patients in intensive care had sepsis. Sepsis is a life-threatening reaction of the body to an infection, and severe cases need to be dealt with immediately. A point-of-care biosensor detecting the early signs of sepsis could prevent the patients from unnecessary suffering, reduce the usage of antibiotics and hospitalization costs. Our biosensor uses a microfluidic chip. The chips require only a single drop of blood, and IL-Sense will detect interleukin-6, a marker of this condition, within minutes. KU Leuven Team Pulse is ready to present IL-Sense, which will bring measurable improvement into modern medicine.
Hi, I'm Chris, and we are SensUs. We are a team of interdisciplinary scientists and engineers from North Carolina State University in the United States. For the past several months, we have been hard at work in our research facilities developing a novel biosensor which quantifies the concentration of interleukin-6, a key biomarker of sepsis. Our biosensor is fabricated using a unique method which consistently and reliably immobilizes our recognition element. We also implemented a label-free measurement technique which minimizes sample preparation and is more cost-effective. Our device was designed to be mobile so that nurses and emergency medical technicians can carry it with them and evaluate patients wherever they are. Every aspect of our design was kept as simple as possible so that our device is easy to use and can be rapidly integrated into current medical protocols for sepsis evaluation and treatment. We hope to see you at our live pitches.
We are Team SensWork, located in Wageningen, City of Life Sciences. Here, on our sustainable and green campus, we came together to form a diverse student team with an expertise in biotechnology and molecular life sciences. Then our challenge started: how to improve sepsis detection in terms of time and sensitivity. With our biological and chemical backgrounds, we focused on the optimization of our membrane, antibody and conjugate combination to create the most specific assay for IL-6 testing. Our biosensor is based on a lateral flow assay with fluorescence ensuring real-time measurement and quantification of IL-6. We use a reader that can send the acquired data directly to your laptop. It is a straightforward point-of-care solution for sepsis detection that can be optimized even more in the future. Intrigued? Come and find the Wageningen University team, SensWork.
Every year there are approximately 49 million cases of sepsis worldwide, of which 11 million result in patient death. Not only does this disease put pressure on health systems globally, costing more than £10 billion in the UK alone, it can also impact the physical and mental well-being of patients and their loved ones. Rapid detection of sepsis is crucial, as for every hour of delayed treatment can lower the probability of patient survival by 8%.
After an extensive research, sepsis team developed a self-calibration point-of-care optical biosensor that can measure IL-6 concentration in blood plasma in just 5 minutes with a single button. This biosensor also features a self-calibrating technique that can eliminate the variations during the production and consequently provide less complexity for the user and improved results. If you would like to learn more about this novel technology, join us in our pitching session.
Sepsis is normally diagnosed by symptoms, meaning that by the time people receive their care, they are already quite sick. We of Twentis 22 have been working on a solution that detects sepsis before someone is sent to the hospital. Using an optical sensor, we are able to detect the concentration of IL-6 in the patient's blood. Our measurement technique is based on micro-ring resonators. It uses light to measure chemicals. A wide spectrum of light is put through the ring, which resonates at a certain frequency, emitting light outwards. The resonance frequency is dependent on the ring's surroundings. Our chip is coated with a hydrogel layer. To measure IL-6 specifically, we functionize the chip by attaching anti-IL-6. The attached IL-6 changes the resonance frequency. The chip gets regenerated using a strong acid, making the chip reusable. Initially, we are planning to place our product in nursing homes, as elderly are more likely to develop sepsis. Early detection could make a significant difference here.
Sepsis, sepsis, sepsis. I think you all have heard about that. But can you imagine a world where the words sepsis and problem are not related? Well, our team can. We developed an aptamer-based biosensor. On our golden electrode, we immobilized IL-6 specific aptamer with methylene blue. So now we have our beautiful functionalized golden electrode. IL-6 present in the sample interacts with the aptamer, which changes conformation upon binding. We can electrochemically measure conformation change, which is proportional to IL-6 concentration. Isn't it amazing? And this is just the beginning. There are numerous advantages in our device, unique, fast and reliable for early detection of sepsis. We are ambitious, with many possible developments in our mind, but what do you think? Come and discuss it with us in our presentation. We are UpSense.
ToucanSense. The first team of TU Darmstadt consists of 15 students from various fields of research. This year's theme is sepsis, an infectious disease that claims the lives of 10 million people each year worldwide. Therefore, it is imperative to detect sepsis as quickly, simply and reliably as possible. To face this challenge, our aptamer-based biosensor detects the biomarker interleukin-6 within minutes. On the surface of our self-printed electrodes, immobilized aptamers bind to the interleukin-6. The impedance change is amplified by gold nanoparticle labeled antibodies and read out digitally by the reader instrument. One of the biggest advantages of this method is the reusable nature of the cartridges that can even be completely recycled once they reach the end of their lifetime. To learn more about our sensor, please join our presentation. This is ToucanSense. Together, we can sense the future.
This is Mark. He has been hospitalized because of an infection. Doctors still don't know it, but the infection is starting to go into his bloodstream, setting off inflammation and increasing levels of interleukin-6. These are all signs that Mark is entering sepsis. Currently, we have no fast diagnosis for sepsis, but what if a pencil could give us the solution? The core of the pencil is made of graphite, which can be divided into graphene. Graphene is a two-dimensional material made of a single sheet of carbon atoms with unique properties such as high sensitivity, conductivity, and lightness. It is also cheap. So what if we build a graphene biosensor? By adding a single drop of blood to the biosensor, we could detect increasing levels of IL-6 so doctors could know when and how to act to treat Mark. Having a device to detect IL-6 levels in a fast and sensitive way could be a step forward to fight a worldwide medical emergency, sepsis.
Yes. So thanks again to all the teams for making such intriguing movies. Maybe we can give them another warm applause. I think it made us even more curious to find out more about their biosensors. So let's get through the program. So next up are pitches by the teams. There will be two different kinds of pitches. One is focused on more the technological aspects of the biosensor, and the other more on the translational potential, so the business models of the teams. So you also have a program booklet, and in the program booklet you can see the exact scheme, and you can see which team has to pitch when and where. So next up at 11:30, you can have in the Atlas Hall, you can have a talk to the partners and to the teams. They will all have a stand over there. And after that, at 13:45, we will have again a round of pitches by the teams. And then at 4 o'clock, we will come back here for a keynote lecture of Matthijs Cox, and he will have a keynote lecture about real-time sensor technology to facilitate precision medicine for sepsis patients. And then we will continue here also for the award ceremony, where we will find out who the winners of SensUs 2022 will be, and then we will close off the day. So I think this was it for the opening ceremony. So we wish you a very inspiring and beautiful day, and go and enjoy it.